everybody. Is there a way to turn this off? I assume there is. Enable mini-mail. Let's turn that off for now. Welcome to probably the zeroth episode of the ComputerCraft challenge. Now, a lot of you guys probably don't know what that is, and I'll mention that I actually found out about it from this YouTube video that I found on YouTube, Gaming with Ben, the ComputerCraft challenge. That's where I originally started watching. Now it looks like other people have done the same kind of thing. Like I did try and watch some of these other episodes of other people doing it, but I originally, when it was introduced this from Gaming with Ben on his YouTube channel. And I mean, his videos are, what, 7 years old? Yeah. And that's probably back on 1.7.10, I'm guessing. So it's a little bit old by nowadays standards, right? So I thought maybe we could do it here in 1.12, you know? And eventually in 1.15 or 1.16 or something. But for now, we're going to try 1.12, right? And the other little caveat I've decided to add to this this trick is I'm going to be using Open Computers, not ComputerCraft, because I am a little bit more fond of Open Computers. It feels like there's a little bit more you can do with them. The way the programming is feels a little more logical, maybe. I don't know, maybe it's just me. But we're gonna try it with Open Computers. Now, I'm going to stumble through setting it up here for us, and I'm going to let you guys watch, see how I set it up, because I always stumble through it every single time. So I know if I'm stumbling through it to try and get it set up the way, I want it, then I know you guys are probably going to struggle too. We're going to quickly switch over to creative. Yes, I've got cheats on, but that's just in case things go bad, or in this case, so that we don't get attacked by creepers while I'm setting this up, even though it's daytime. So, some things we probably want to get a hold of, and also let's make sure these books are still here. Yeah, they're still here. Not carpet. That's not what I want. So, first things first. To actually make the turtle, which is ComputerCraft, in Open Computers, it's robot. That's what they call it, right? It's a little robot that goes around the world. Okay. So, in order to make those, we need this electronics assembler, and it even says allows constructing robots and other devices from a number of different components or computer parts. We only need one of these before I accidentally click it and create 400. And you'll see that we can put this down, and it does have a power bar at the top, but it does not actually need power, to my knowledge. And this is where we're going to actually start making the robot. But there's a little bit of a... Oh, there's two of them here for some reason. I think this one's fake. Let's pick that back up. Weird. There's a little bit of caveat. This needs... the robot needs a hard drive on it. And the hard drive needs to be able to be booted too, right? This is going to get a little confusing because it's computer related, and some people aren't very computer familiar. I've been in IT a little bit, so and I build computers on the side, so I know a little bit about how these things work. But we're gonna get that set up. Basically, we need a hard drive. Like, we can throw all the components in here. Like, let me grab some stuff. I can throw a case in here, and I can start tossing in CPUs and stuff like that, and that's fine. But before that, we need a hard drive that actually can be booted to. We need like an operating system running on it, right? And that's the part that you can't. Well, I mean, first of all, you see here that if I like type in robot, you can't just create a robot like you can in ComputerCraft. You gotta like actually build it in the assembler. Even with my cheats, I need to still build it, and I also need to still build the hard drive with a bootable space on it, something that you can boot to and it'll run. It'll run a program. So, and like I can, if we search hard drive, or I guess they call it hard drive, you'll see this is all we got. They're just blank hard drives. So I can't just like easily, quickly slip that on, right? So what we're gonna do is we're gonna follow this little tutorial, and I'm gonna walk through it with you guys. I've got it pulled up right here. This is literally the getting started tutorial for Open Computers. This is the preliminary, and I do this in creative since it's not really part of the challenge. It's just the setup, right? We're just setting it up in the first place. So, first thing we see here is he's got a case, a screen, and a keyboard, as well as some sort of power. So, what I usually do when I need power is I'm a big fan of thermal. I like the thermal series. And I know they've got an energy cell. And now I don't see a creative one, but I know that if I plop this feller down and get rid of that, we can probably create like an upgrade kit. Maybe it's not called upgrade. Maybe it's just kit. Yeah, the purple one. Creative kit. Converts any block into a creative version. So this will turn this into an infinite source of power. You can see at the top there's 50 million RF or whatever. And if we mouse over here, it says infinite RF. So like, there's our source of power right there. And it should be, it's already on output mode everywhere. Okay, cool. So there's our power. So next thing, we want to go back into Open Computers. And we need a case. So case. And I'm just gonna use a tier 1 for this. Like, I don't need, I do have a creative one. I guess I could have done that without the source of power, but that's okay. We just need to temporarily run this anyway. So let's set up. You can see the bar at the top. It's filling with power. So it does have power now. We can get rid of this. Get out of here. Next thing we need is a screen. And again, we don't need anything fancy. Tier 1 will be perfectly fine. And then we need a keyboard. This bad boy, and I'm gonna do exactly what they did and just whack it on the side, so it's out of the way. I don't have to look at it all the time. You know. All right. So that's the first few steps. Now, when we open this case, you'll see that there's some other components we got to throw in here, as well as one right here. So this top one, this middle one is going to be the CPU. So the first thing we want is the CPU, or I guess they probably type it out, Central Processing Unit. Level 1's perfectly fine. A tier 1. We don't need anything special. Next, below that, these two here, these are sticks of RAM, which they call memory in here, I believe. So we'll just whack 2 sticks in there. You can go with 1. I'm pretty sure it's frowned upon in real life, so by default I just kind of do 2 sticks all the time. Next we've got extra cards like graphics cards or internet cards. Now here we probably just need a graphics card. I don't know if it's required, but just in case it is, I'm going to do it, and then, because we're just going to end up trashing this stuff anyway. We're not going to keep it. The only thing we're keeping is the robot that we make after this. And really all this is setting up is just the hard drive that we use for it. So this is kind of like a big turnaround just to get the robot going. So you can see they've got a graphics card there, and they've also got a hard drive, and this is an EEPROM. And the EEPROM is just a I think it's a rewritable version of, does it say it's rewritable or what? It's just a place where you can store information, and usually what you'll put on here is a BIOS, which is no, we don't want that. We want the already completed one. This guy, Lua BIOS. The BIOS is just the first program that runs between the hardware and the actual OS or whatever you've got, whatever software you've got running on top. It's the middleman sort of. So you need him there for sure. And then hard drive. That's the other thing we're missing. Hard drive. And they don't need to be anything fancy. You'll see all of these now have like a letter, like letters. We got EBEEE here. They've all got like little codes in here. The only one I'm worried about is this hard drive, honestly. That's the important one here. Now you'll see that he says, and I mean I can demonstrate this here, if we turn it on, well, there's nothing on the hard drive. So it craps itself. It doesn't know what to do. It says, I don't know where to run from. I don't know where to start running. It's just got a hard drive and there's nothing on it. It's completely blank hard drive. So we're going to turn it off, and you'll turn off. Oh, is it? It's automatically off? Okay, whatever. Yeah, okay. We're just going to ignore that. You'll see he covers it here, and he says, okay, well, grab a disk drive and throw an OS disk in the disk drive next to the computer case so that it can run. And this is like an install. This is like, in real life, you'd have either Windows 10 on a card, or you might have a flash drive with any OS. I mean, you got Windows, you got Linux. So that's all we're doing here. We're getting that set up. So here's our disk drive. We'll whack this guy right here, I think. And then we also need a copy of OpenOS. See, like, here's some other, like, I don't know what these others are. I really don't. I'm only interested in OpenOS here. This is essentially the flash drive in a sense. It's basically what it's the same as. It's a floppy drive in this case, but nowadays you don't really see floppy disks. So if we turn this off, turn it back on, which I think it did, you'll see it's just spitting out stuff, and that's because it's running from this drive. Because remember, the hard drive inside here is completely blank. So right now we're inside this thing right here. Okay? And it even says OpenOS. Alright, so first things first, we want to install. That's all we want to do. And it says, are you sure you want to do that? Heck yeah, let's go. So now it's writing all of this information, all this stuff onto that hard drive that we just threw in there. And it asks if we want to reboot. Heck yeah, let's start over. Let's start over. So now I imagine we're probably running from the hard drive. Technically, in a real computer, you would check first. You would go into like the BIOS and make sure it's not booted onto this, or you would just turn it off, which is what I could do here. So now it's off, and we can just completely destroy that and toss this, because now it doesn't show it in any way, but now this hard drive has OpenOS installed. Oh, it does say it. It says OpenOS on there. So it has OpenOS installed on it. So now if we turn it on, there's no disk drive or anything, the floppy disk is gone, we are now booted into that hard drive right there. So, yeah, and it's running OpenOS. So this is an actual operating system. Now, OpenOS is a lot like a Linux type operating system, where we've got we've got directories, we've got folders. So right now we're in the home folder. And if we go up, if we use CD, which changes the directory, that changes what folder we're in, and then we type which folder. And in this case, we could say, like, if there's a folder inside this home folder that's called like blocks, then we could say that. Or if there's whatever the name of the folder is. But we want to go up a folder. We want to go out of this folder, back into the top layer. If we do that, you'll see we're now just at /. There's no folder or anything. Another thing we can do while we're here is we can actually do ls, which stands for list. And this will list everything inside the current folder that we're in. So these are all the folders or files inside of just /, the / folder, which is often called root. And you'll see we've got home right there, which is what we were just in. So if we want to go back into home, we say cd home. Now we're back in home. And there's nothing in home because that's kind of like Windows's like user folder. Like if your name's Jacob, it would be /Jacob, I guess. Now I think they do have users in this as well. I don't know how to use it much because it's a little beyond me, but we'll probably get to it at some point. Anyway, they cover in this tutorial how to write like files, and I'm gonna copy them because it's a good practice. So they say from root change directory into the temporary folder. Now we can also, as you can see, they did it from home. So if we go to home and we're in home, there's no folder called /tmp here. The folder /tmp is actually /, which is root in this case. If it's just a / and then a name, / is root, right? So we're saying instead of in the home folder like we're in, change completely to root tmp, which you can see from before when we said ls, there is a tmp folder right here. And tmp is a special folder. Let's change into that. I don't think it has anything in it. Yeah, it's empty. TMP stands for temporary, and go figure. It is a folder that is completely wiped every time the computer shuts off. I think it's hard resets only, but that's kind of unimportant, basically. So if the computer shuts off, the temporary folder is completely wiped. So we can write something in here and it'll be gone when the computer starts over. Now I'm not going to do that. I'm going to instead save it in the home directory because I want to be able to access it again later to test that this drive is all good and working and everything. So to create a new file, file. I suppose you could do folders this way too, or maybe it's makedir. I forget. But to make a new file, you use the word edit, and that's also for if you want to change a file that already exists as well. You say edit and then the name of the file. They used test.lua. I'm going to do hello world.lua because every programmer starts with a hello world usually. It's kind of a thing. So now we're writing to a file here, and it says the name down at the bottom, and it says that it's a new file. We can write whatever we want. Now it's a Lua file, so it's not going to do anything, and it's just a text file right now, but it's treated as a Lua file, meaning if we type in some special code that is in the programming language Lua, then it can run this file and operate on it. It can use it to do things, right? So one command that is inside Lua is the print command, and print literally just you give it a string or you give it some words and it'll just throw it onto the screen for you when you call it. That's all it does. It doesn't do anything fancy. You could use this to kind of tell yourself later where in a program you are. You could use it to say, oh, we're executing this piece of the program. So it's good for debugging or for checking for issues or troubleshooting. So we're just going to say print hello world, which just means print the words hello world, this thing in quotes. Just throw it onto the screen when we call this. And then to save, it's Control S. It says down at the bottom. So we hold Control, press S, and then it's gone now, but over here you can see it says press Control W to close. So now, if we check and see what's inside the home folder, you can see hello world.lua is inside there. And because it's a Lua file, and this computer runs on Lua, we can call it. So if I say hello world and spell it right, .lua, and you might even be able to just say hello world. What does that do? See, look, there you go. It runs the program, and so what it did is it printed hello world to the screen, it showed hello world to the screen, and then it returned us back to, it ended the program, the file finished, and we're right back to browsing the folders as we want to. So now let's go into this how to use hard drives, because there's a little bit more to it that can kind of get confusing. And I don't know if this is entirely necessary, the whole mounting thing, because the fact that we're able to boot into this in the first place without a floppy disk or without the help of some other disk tells me that it's already mounted. So I don't think this is entirely important, but we're going to do it anyway because that's what they did, and I trust the maker of the mod to tell me what to do, right? So basically mounting is where you tell the computer that this directory, this folder, is where this other folder is located. And usually you want to do that when you first get a computer that needs to be configured. Sometimes they need to be mounted in certain ways. This isn't true for Windows really. They usually do kind of like an auto mounting type thing there. But for Linux usually you gotta do some mounting on your own. And as such, since this is modeled similarly to Linux, it's gonna follow very much the same principles. So if we do df, which I'm guessing that stands for display file system because we've got file system up here. You can see we've got OpenOS, which is the operating system, and it's mounted already on root, on just slash, at the very top of the file structure, so to speak. So I'm pretty sure that means it's already mounted. But again, we're going to do what they did. See, they've already got it listed as mounted too here. We're going to do what they did and mount it anyway, remount it really. And then there's the temp file system, and that's the one that erases every single time. And then whatever dev file system is, we can't even touch that. It says not applicable, not touchable, I guess. So we're going to leave that alone. The first thing they say to do is you should probably, they want us to label the hard drive. So we'll label it. We'll give it a label. That's fine. So the -A command, or I guess switch or flag, if you want to call it that, I'm pretty sure that just says whatever name, whatever identifier comes after this is what we want you to label. And they put 92A because their hard drive started with a 92A in the ID section. So if we go to our hard drive here, you can see there's a number or letters down at the bottom. We've got EBEEE there. So that's the identifier, so to speak. That's how you can identify a hard drive. But what we're going to do is give it a name instead of a bunch of letters like it did. So EBEE, that's probably enough. I don't think I need to give it more. And then whatever we want to call it. Let's just call it our hard drive in camel case. Boom. Now I don't know if it'll show up in here. It does not. But now if we do df, you can see instead of OpenOS it says hard drive. We've kind of changed the name there instead of OpenOS, which we probably could have left that. But all hail the supreme leader, right? So, yep, and he's showing the same thing. So now he's talking about mounting. So now he suggests we mount. What is test? I guess that's the. Oh, interesting. His has got a special mount point, or did he just run that and it changed? Yeah, his looks a little different, but whatever. So we're gonna run this last line. I'm not gonna worry too much about this. I see he labeled it, and it's now got like test and OpenOS as two separate like things. So I don't know if that's an issue. Does he say he rebooted it anywhere? Oh, his is listed up here. I see it. That's where it had that ugly name, whereas ours just says OpenOS. That's probably with the floppy still in. So this is probably his floppy drive that he was talking that we had earlier, the disk drive. And then this is the hard drive, and ours is already configured or named to OpenOS, I guess. So, and it's already mounted too, so I don't know if we actually have to do this part. But for the sake of copying him, we'll just copy him. So we're going to say mount, and then the name of the hard drive, whatever drive you want to mount, or whatever type of file, type of storage medium, right? So you've got, in real life, you've got SSDs, hard drives, NVMe, the super fast SSDs. There's all kinds of stuff, right? So here we want to say we want to mount the thing we just called hard drive, and we want to mount it at he put /test, so we're going to mount it at /HDD because I'm lazy and that looks good. Alright, so the way this works is this slash is root, right? Just like we saw TMP and dev, and just slash. So inside of root, there's now there's a mount point, which I believe in this case just refers to a folder called HDD, and that's where this hard drive starts writing from. And if we go df, it'll probably say that. No, it does not. What if we go up to root and we do ls? Yeah, look, there's hard drive, HDD. So there's an HDD there. And if we go into that, it should be empty. Oh, it has stuff on it. Well, either way, this is the stuff inside the hard drive right now, and this is all the stuff that is needed to actually run it, like to get it to start up and boot from the hard drive itself. So the next thing they say to do, you can see that he is, or they have changed the directory into that this mount point they just created, which ours was called HDD, so we're in it already, like they are. And then he creates a new file called autorun.lua. And this is a special file that is run as soon as the computer turns on, or in our case the robot, when we put it in there. And he's using this to tell it to mount automatically, I think. Yeah, mount. So we're going to do the same thing, because we want it to automatically mount somewhere for us to like write files and stuff to. So we're going to say edit autorun.lua, and that'll create a folder inside of HDD called autorun.lua, and this is the garbage he says to put in there. And I don't know what all of this means. I don't know what proxy equals ... means. It's some sort of Lua convention, but the local command just means create a variable that's unique to this specific file, right? It stays inside the scope of this file. So as soon as this file ends, you can't say in some other file, in this case fs, you can't say fs dot, right? We'd have to redo this top line for that other folder to do the same thing. So we're going to say store inside of the variable called fs, store whatever you get back from this require command. And I believe the way this is being used is there's a system file called, or you could call it an API almost, called file system. And when we say require, it goes and it opens and runs, I don't know if you'd say runs, but it loads that special file, the special API file system, and whatever handles or whatever come back from this, it stores them inside of FS. And this allows us to run commands and scripts and commands basically that are inside of this file wherever it is by just using fs dot. That's this dot parameter, or dot, what do they call it? Accessor, I guess. You put a little dot and then you say, so basically we're saying in this, here I'll write it out, let's get this proxy thing first written out. Proxy equals ... which again I don't remember what that does. It's a Lua thing. Alright, fs.mount. So we're saying inside of the fs variable, which we just put file system, this API into. So inside of that API, or that file or whatever that we grabbed, run the command called mount, and run it with these properties, these commands. Proxy is the first input, and the second input is / in our case hard drive HDD. And again, I don't know what proxy does, but this looks like it probably mounts the hard drive itself to this location that we have specified. Basically the same thing we just did earlier, except this will stay after we turn off the computer, whereas what we did earlier may not. I don't think it does. So this way it always does this right when the computer turns on. It automatically mounts it for us in this exact configuration. So we're going to say Control S to save, Control W, and I think Control W stands for write. Although in this case we're just closing the file, so I'm guessing Control write. But anyway, so now if we go ls, you can see autorun.lua is right there. And if we want to open it again to look at it, we can say edit autorun.lua. Boom, there it is. There's all our stuff from before. We could just Control W out of that, get out of that. I think that's all we need to know. I think this hard drive is ready to go. So with that, I'm going to leave this alone. We're going to shut this bad boy down. Yep, all good. Yank this hard drive out, and we're going to start actually building the robot. I know, exciting, right? Now this part's a little finicky, and you'll see there's a reason I used a computer case tier 3, and I'll even show you. I'll take this one out, and we'll start with tier 1, right? So here's a tier 1 case that you put a case up here to make a robot, and then you throw in the components inside. The same way we did with this computer, except instead of throwing the case down in the real world, we're just throwing it inside this assembler. So you can see we've got the same kind of things. You'll see we've got a hard drive slot right here, which is where this guy's going to go. This is our already configured hard drive. And then this looks like the EEPROM that we had earlier. This guy. This Lua EEPROM, which I think I might even just steal this guy. So this guy goes up here on the top. It's just something so that the computer can know where to look for hard drives and stuff. It's configuration for the hardware, the actual pieces here. I'm actually just gonna steal all of this because we need all of this in our robot. Not this specifically, like we could just go in and grab a new one, but I'm happy with the tier, like the level that all of these are. Like I don't need anything fancy. This is gonna do just fine. It's not horrible. We just needed that hard drive set up. I don't even know if we need a graphics card, but I'm gonna leave it because it's possible we do. And I don't really want to have to redo this whole thing again. Like, it's kind of a lengthy process just to begin the begin. But anyway, so you'll see we've got 3 slots up here, and if you mouse over here, you'll see it says, "Hey, don't forget a screen, a keyboard, and an inventory upgrade." You should have those for a robot. You should. You can do it without if you want, but I don't. There's certain reasons you shouldn't do it that way, you know. So let's grab a. In fact, we can yank this, and I'll grab the screen too. And we're just gonna throw this stuff up here. And it wants an inventory upgrade. Now that's this guy right here. We can read it, and it says this gives us an inventory space for the robot or the drone. So in ComputerCraft, they've got a little 16 by 16 square down the bottom right where you put all your you can put your stuff there. It can pick things up for you, whatever. So this is what this is, and 1 is for 16. If you wanted to add 2, I think it's 16 per. So if you added another one, it'd be 32, etc., etc. You'll see we've only got 3 slots here, and I don't know what these are for. But you'll see we can assemble it right now if we want to. But the reason I'm not going to is because there's some functionality here that there's some functionality in ComputerCraft that isn't currently in this robot that we've just created, right? So, for instance, robots require power, so they've got a little power bar inside them. It's electricity, basically. The same way ComputerCraft turtles need fuel. So the only issue is they don't. Open Computers doesn't have just a simple way for you to fuel it up. Usually you would like get a charger of some sort of electrical charger, or a generator in the real world and plop it down, right? Like you'd plop one over here or something and then charge it up that way. Well, we're not going to do that. We want to emulate this ComputerCraft behavior as closely as possible. So what we're going to do is we're going to, first of all, what we're going to do is we're going to grab this generator upgrade. This is the first thing. This is essentially the same thing as the refueling process that comes with ComputerCraft. So it's an upgrade, right? So we're going to throw this down, but you'll see if I mouse over it, like I would normally mouse over these things while they're over here. Like if I mouse over this, it says, oh, it goes up here, and if you mouse over here, you can see that goes up there. But if we mouse over this, there's no spot for this, and the reason is because we've got a tier 1 case. So I'm going to use a tier 3 because tier 2 doesn't have enough slots either for all that I need. So I'm going to use a tier 3. You'll see now we've got a whole set of 6 upgrades here, and this can go in one of those slots. So we're going to put this in that slot. Another thing I want to have this guy, the inventory controller upgrade. This allows the robot to pull and push from inventories out in the world. And I want this because I'm actually going to take the ComputerCraft challenge a step further and see if I can do like a complete no hands, as in if I need to craft something, I have the turtle crafted. If I need to open an inventory and do something inside the inventory like a chest, I'm gonna have the robot do as much as possible, preferably all of it. I'm gonna see if I can get away with all of it, and this is what allows me to do that right here. This guy, that lets the robot do it all for me. Now, unfortunately, in some cases this doesn't always work. I found that some of the Tinker stuff doesn't like to play nice with this for some reason. So in that case, I might try to either find an alternative, maybe just a regular crafting table, for instance, if it's the crafting tables from Tinkers or whatever, or I may end up doing it myself, but I really don't want to do that, so I'm probably going to try and find an alternative first. Alright, now there's one last one that I want, and that's the crafting upgrade. This allows the robot to actually craft in its inventory instead of, me doing it in my inventory or whatever. This allows the robot to do it for me. So that's the other thing we're going to include. And I think that is about everything. So what we're going to do is we're going to build this and see, and just, yeah. Let me double, triple check. This all looks okay. Got the hard drive ready to go, so let's just bonk. There's our robot. It's got all this stuff, and you can see stored energy at the top. That's how much energy it starts with. So we've got to make sure we get wood by the time before that energy ticks down to 0. Otherwise, that's it. Challenge is over. We've completely failed the challenge. I have to start over or something. And it gave it a default name and everything, Lizzie Trickster, I guess, which is fine. I'll probably rename it later or something. But that is it for the robot. Let's just get rid of all this stuff because we don't need it. And we don't want it in our world when we start the map, when we start the challenge. And we'll just let's turn this off too. Well, that is it for setting up the ComputerCraft challenge. Next episode, we'll actually start doing it. We'll plop our turtle down and our robot down and go and find some wood. And it'll be daytime. I'm gonna wait until daytime to actually start the series. But the other thing is, I don't want to kill the baddies. I'm gonna see if I can get the robot to do all the killing for me. And if I get attacked, I'm just gonna run away. Or I'll just be careful and hide inside a hole somewhere. That's my plan. Probably not the best plan, but I'm trying to go completely no hands. And what I might even do, what I'm thinking I'll probably do, is place them down and switch into adventure mode, so we can even, there's a whole nother layer of, I can't touch anything. So with that said, guys, I hope you enjoy, and I'll see you in the next one.